Good evening, sir.
Yeah, good evening. Um, Yuvraj,
Yes, sir.
have you watched the bare metal pick video and C++ video?
C++, yes, sir. Complete. It's need three more videos is there for C++. Bare metal
Mhm.
is completed, sir.
Hmm. Any doubts so far?
Uh, in C++ only having some doubts. That
Okay, have
one
you
I
noted it
will.
down?
Yeah, I have noted.
Okay. So
Yes.
once you finish the C++, okay, just let me
Okay.
know. We will connect one day and
Okay, sir.
we will clear this doubt.
Okay, sir.
Mhm.
Sure.
Yeah.
Yeah. Sir, i- in
Hmm.
in this module we are covering CAN protocol, sir.
Yeah. We will be covering CAN protocols.
Okay.
Yes.
And I have a doubt that
Hmm.
what we are doing is the single core controllers, right? Now
Yeah.
we are studying.
Yes. Yes.
And what about that dual core and tri-core controllers? It will be the same or need some more?
Um, no, it is actually a different. Like
Yeah.
we will be having. Okay, so here we have one main.c, right?
Yes.
Okay. In tri-core, what will happen is we have core 0, core 1, core 2. Okay. Inside core 0,
Okay.
you'll be having a source code that is main.c. And core 1, you'll be having one main.c. And core 2, you'll be having one main.c.
Okay.
Okay. So initially, whenever you boot the program, code
Mhm,
0 will boot first. Okay. After that,
mhm.
core 1 and core 2 will boot. Okay. So you can actually able to write three different programs in three
Mhm.
different cores.
Yeah.
Okay, so that
Yes,
is
sir.
what a multi-core thing is. So you just have to configure each and every course.
Okay.
So when this core has to be triggered, okay, and
Mhm,
also you can able to send the data from core 0 to core 1. That
mhm.
also you can able to do that.
Okay. Then the
Hmm.
bootloader concept will be completed with this or to do separately?
With this device driver, we won't cover bootloader.
Okay.
Um, okay, I will try to cover that one. Okay, since we already covered bare metal, so if we covered
Okay.
bootloader also, it will be a complete device driver package. Okay, I will try that in the last class.
Okay, sir.
Hmm?
Thank you.
Yeah.
Yeah.
Okay. Did anyone saw the recording from the link? Is my voice audible in that recording? This device driver and RTOS recording. Anyone? Okay, so we will start the class. So yesterday we stopped with this bare metal programming, right? I think, yeah.
Yes, sir.
So I'll just open the data sheet and I will open the reference manual. So where I have written that. Okay. Okay, so yesterday we discussed 5 points, right? So everyone remember what are the 5 points? Point number 1, I think
Yes,
6
sir.
point. Yeah. First one is we need to
Um, we need to set RCC for both
yeah.
timer
So
6
we need
and
to enable the RCC for
both the
first we need to
timers
enable
and
for this is PA5, that is port A. Okay, and for this timer 6, I think. Okay, so in my case yesterday we did for timer 6. Okay, you can use any timer you want. Okay, next one is just a minute. Yeah, second point.
enable enable APB1 for time. Yeah, that both
Yeah, that is
RCC we
this
need
one.
to and make PA5 for output.
Okay, so we just need to set the mode for this PA5 as an output. Okay. And third step, we need to set the prescaler.
ARR count.
Prescaler, ARR, and counter. Okay. So 3. And fourth one is we need to check the status flag. Okay. And the next one. 1, 2, 3, 4.
Toggle PA5.
Yeah. So we just need to, once this flag is set, then we need to toggle this. And then we need to reset the 6th point.
Status.
Yeah.
Status.
So we need to reset the status flag. So we are just going to do all these steps one by one. Okay. So the first one is we need to enable the RCC for PA5 and timer 6, right? So we just need to directly go for our architecture diagram and we need to know which 2 buses we need to enable. Okay, so our architecture diagram is this. Okay. So for the GPIO A, I need to enable this AHP bus. Okay. And for timer 6, where is timer 6? This is my timer 6. So I need to enable the APB1. So I need to enable the AHP and APB1. Okay, so these 2 things I need to enable. That is my first thing. Okay. Right, I will open my STM. We will just do this parallelly. Okay, so I'm just going to close this project. Okay, so file new STM32 project. I'm going to create a new project for this bare metal programming. Okay, so for the board selector, I am selecting my STM32F334. Next. So this is timer delay bare metal. Okay, so for bare metal, I'm not going to configure anything over here. So I'm just going to close this. I'll directly open my main.c. So this is where I'm going to write my code. So I'll just delete everything. Okay, I'll just maximize this. So first one, I'm just going to add the header file. So for my case, it is stm32 f3 xx.h. Okay, so this is the header file I'm going to add for this program, and then int main. Okay. So the first step, I need to configure the RCC, right? So first I need to assign the clock pulse for both this port A as well as my timer. So I'll directly go to my reference manual. Okay. So in this, I'll open this first one. I need to enable the RCC, right? So where is my RCC? My RCC is in 8th one, reset clock control. So I'll open this. In that RCC register, I'll open that. So if I go to RCC APB enable 1, enable register, or AHP enable register. So this is status register. This is also status register. Yeah. So this is AHP enable register. First one. Okay. So I need to enable the AHP for my GPIO. So which GPIO I'm going to use? I'm going to use my inbuilt LED, right? So that is nothing but my PA5, that is port A. Okay. So where is my port A? This is my port A, that is 17th pin. I'm going to enable. Okay. For my port A. So I'll directly write this RCC. Okay, so this is AHB enabled register, right? So AHB enabled register. I'm going to do an OR operation with one left shift for 17 times. Okay, so because here I need to enable the port A 17th pin. So I'm just left shifting the one for 17th time and 17 times, and then I'm just going to do an OR operation with this register. Okay, so this is for my GPIO EFI. Okay, so first step is done for the port A, and the next one is I need to go for the APB1. This is my APB2 enable register. I need APB1. Why APB1? Because my timer is connected to APB1 only. Okay, if you are using something like a timer 16 or timer 17, then you need to enable the APB2. So depends on this data sheet, or if you are using in some other board, refer that data sheet where your timer is connected, enable that particular bus. Okay, so that is you need to do. So this is my APB1 enable register, and which timer I'm going to use? I'm going to use a timer 6, right? So where is my timer 6? This is timer 2. Yeah, this is my timer 6. You can see timer 6 enable, 4th bit. So I'm going to enable the 4th bit. Okay. So I'll directly go to the program RCC. Now this is APB1 enable register. Okay, so this is what my enabled register now. So I need to do the OR operation 1 left shift for 4 times because my timer 6 is in 4. Okay, so I'm just going to make this 4. Okay, so this is for timer 6. Okay, clear? So if you're using some other timer like timer 2 or a timer 3, okay, then you need to enable that particular bus. I mean, particular register 0 or register 1 or register 4 or 5, depends upon which register you are using. You need to do that. Okay, clear till now? Any doubts? So we did the first step. This one is done. Okay, next I need to enable the mode for port A 5th pin. Okay, so for mode I need to, this is on GPIO, right? So I'll need to directly go for this GPIO, general purpose input output. In this GPIO register, mode enable register. Okay, so where is my pin number? Pin number is PA5, right? Okay, so this is 5. So where is my 5? This is my mode 5. And I need to enable the 11th bit and 10th bit as a general purpose output mode. So I need to make 0 and 1. This we already did in our LED blink program using bare metal. So 11 has to be 0 and 10 has to be 1. Okay, so this I need to enable for making this as an output. Okay, so I'm just going to give GPIO A, this one, mode enabled register. Okay, so first I'm going to do with then 10. So R equal to 1 left shift for 10 times. Okay, and similarly, this I have to do for the 11th bit as so this is mode GPIO A, mode enabled register, R equal to, sorry, not R. We just need to do an AND operation. Okay, with and negation of 1 for 11 times. Okay, so this is for bit 10 as 1, and this is for bit 11 as 0. Okay, so here I will write it. Configuring PA5 as output. Okay, clear till now? Any doubts?
Clear, sir.
Okay, so this part is done. That is my GPIO. I have made enable for this RCC and I have configured it as an output. That part is done. Then I need to set some settings for timer 6. I only enable the clock for timer 6. I didn't set any values for the timer 6. Okay, like in prescaler value or your counter value or ARR value, anything. So the next thing is I need to configure. So this is configure timer 6. Okay, so that I need to do. So for that, again, data sheet, I'll open this. So now I'll close this GPIO that is not needed. If I scroll down, you can see there are some general purpose timers for timer 2 and timer 3, and one more general purpose timer for 15, 16, 17. We have an high resolution timer. We have an infrared interface. Then I have a basic timer, that is timer 6 and timer 7. These two are my basic timer. Okay, so I will open this one. Depends on your timer. You just need to open that particular register. Okay, once again, I'll tell you, this is purely depends on your timer selection. Okay, you can either select an 15 or a 16 or a 2 or a 3. Okay, whatever your wish. Okay, you just need to do the same thing for mode selection as well as the RCC also. So here I'm selecting timer 6. So timer 6 register. So first one, I need to set the prescaler. Okay, so I'll directly scroll down here. This is for control registers. This is interrupt enable. This is status register, counter. Yeah, this is prescaler. Okay. So we just need to directly set the prescaler value. This is nothing but your 2 power 15. Okay, so 2 power 15. You will get something like
16-bit.
65,535. 65,535 or 534. Yeah, 535 only. Okay. So 2 power 15. So if you set everything as 1, it will be 65,535. Okay. Or you can directly put the value itself. So there is no issues with that. It is not always needed to put this in the binary form. Okay, you can put the value in the decimal form also. So the register name is TIM. This X is nothing but your timer number, and this PSC for prescaler. Okay, so first one TIM 6, and I just need to use this prescaler, which is equal to. So what is the prescaler value I set for last program? I set 8,000, right? That is 8,000 minus 1. Okay, so I'm just going to give it as in 7,989. Okay, so this is for your 8 megahertz clock frequency. Okay, so for that I'm just setting 8,000. So that will be like an 8 megahertz divided by 8,000. Okay, so this is for the calculation. So I'll get something like an 1 kilohertz. Okay, so I set the prescaler value. Next is I'm going to set an auto reload register. This is ARR. Again, the same thing. It is in 16 bits. Okay, 0 to 15. So we just need to do the same thing for that also. So this is timer number 6, ARR. Okay, so ARR value, I think I have given 1,000 yesterday. Okay, so same thing I'm just giving. It's 1,000 minus 1. So it is 999 again. Okay, so this is for generating 1 millisecond time. Okay, so if we just divide it with 1 kilohertz, I'm just going to get an 1 millisecond delay. Okay, so that is an auto reload timer. Sorry, this is for a millisecond time. Okay, and the next one is timer 6. I need to set the counter, whether this counter has to be a down counter or an up counter. Okay, so that I need to do. So for that, CNT, which is equal to, I think counter is over here. Yeah, this one, counter. Okay, so this count can be an 32-bit, 0 to 31. Okay, 32-bit value we can able to do. So I'm just going to give a 0 for starting from the down counter. Okay, so that is I'm just resetting the clock to 0. So if you want an up counter, you can just directly give this as an that 2 power 32 value. Okay, whatever that value, we can directly give it over here. Okay, so that is possible. And so we just made everything like prescaler, auto reload timer, and counter and everything. So I need to enable the counter. For enabling the counter, so there is something called as an there is CR1 control register. Okay, so this control register, you can see this bit number 0, right? Bit number 0 is nothing but it is a counter enable bit. Okay, when you set a counter value, you just need to enable it. So 0 for disabling the counter, 1 for enabling the counter, which is nothing but the 0th bit. Okay. Similarly, each and every bit will have a same thing like an update disable, update request, one pulse mode, auto reload, preload enable. Okay. So it depends on each and every bits over here. You can enable to set it or reset it. We just need only this CEN counter enable. Okay. So the same thing TAM 6 for the CR1. I'm just going to make this particular bit as 1. That's it. Okay. So TAM 6 for CR1. Okay, I'm just going to do an OR operation equal to this is 0th bit, right? So I'm just going to make this, sorry, this is 1. I'm just going to make this for 0 times. Okay, so this is for enable the counter. So once I enable the counter, this counter will start from this value. That is what this enabling the counters. Okay, clear? Till this configuration. Any doubts? So till now we did only the configuration. Okay, we didn't actually go into the actual program. This is only the configuration part. Is it clear or do I need to explain it again? Is it clear for everyone?
Yes, sir.
Others?
Yes, sir.
Okay. Okay, nice. Okay. So this configuration part is done, right? So now we are going to write the actual code that is nothing but our infinite loop while of 1. Okay. So I'll just write an while of 1. Okay. So inside this, we need to check the status register of your interrupt. Okay. So whenever this interrupt flag enable, then we need to toggle. When this interrupt flag will enable, whenever it reaches this count value, that is 1000. Okay. Then your interrupt flag will get triggered. We just need to check this interrupt flag. Okay. So where this interrupt flag will be available is it will be available in the status register. That is this one, CR1, CR2, yeah, this status register. Okay, timer X status register. In that we have only one bit, that is nothing but update interrupt flag. Okay, so whenever this is 0, that means no update occurred in the interrupt. So whenever this 1 has been set, update interrupt pending. Okay. So this bit is set by hardware when the registers are updated and we need to reinitialize by software. So this counter we need to reinitialize by software. That means we need to manually reset it. Okay. This will be automatically set by hardware, but it needs to be manually reset by software. That is in program. We need to set it. Okay. So we need to check whether this particular 0th bit is 1 or a 0. That we need to check. Okay. So while, okay, I need to set or I need to check this timer of the status register. Sorry, timer 6 of the status register. Okay. And I'm just going to do an AND operation with the 0th bit. Okay. If it is 1. Okay. Or I'll do one more thing. until it becomes 1. Okay, that is, or until it becomes 0, I'm just going to wait in the same particular line. What is meant by this semicolon at the end of a while loop? We won't usually put a semicolon after the while loop, right? What happens if I put a semicolon after this while loop?
Infinitely
Termination.
till that.
Mm-hmm.
Termination, sir. It will
Termination, yeah,
terminate.
termination. Okay, so semicolon is for termination, but why I need to terminate this at the end of a while loop? What will happen? What happens
So it will
if
till in infinite loop. And
infinite loop? This is what an infinite loop is. Semicolon doesn't mean it is an infinite. It has some other purpose. Anyone? Any idea? I think is Ajmal there? Yeah, I think Ajmal or Saravanan has to tell this because I already explained to you this one in our previous module. Have you remember? Ajmal, Saravanan.
Semicolon add பண்ணா அந்த loop continuous-ஆ run ஆயிட்டே இருக்கும். இல்லை satisfied ஆகுற வரைக்கும் on line-லயே loop run ஆயிடுச்சு. இந்த ஒரே
Okay.
command.
Okay, nice. So what is mean by this semicolon is, okay, if I remove the semicolon, what is mean by that? If it is true, it will go inside or it will go to next line. Okay, that is what without semicolon means. Okay, but if I give this semicolon over here, if it is true, it stays in that particular line. Okay, if it is true, it stays in that particular line. Only if it becomes false, it will just go to the next line. That is what the semicolon means. Okay, I'll just write a simple code for you people to understand this. Is that online GTP, right? Okay, I'll just make an int I equal to 0. Okay, so inside this while of I less than 10, I need to print this hello world. Okay, I'll just make this I plus plus over here. Okay, if I give /n, okay, now what will happen is, oops. Okay, now what will happen is this hello world will print for 10 times because this condition is true. Okay, so I'm just going to select the language over here. If I click run, you can see this hello world will be printed for 10 times. So because each and every time this condition becomes true, it will go inside this loop, it will execute. Okay, so that is what this while I less than 10 condition is actually. If it is true, it will go inside. If it falls, it will just come out of that. Okay, so that is what this while loop. If I give semicolon over here, you'll see if I run this, you won't get anything. Okay, it's keep on running because this I is not even incrementing. The I is still
now
0.
it is now it is an infinite loop.
Yeah,
I mean,
no, it's not actually an infinite loop. Okay, here it is I less than 10. I is not even incrementing, so it is infinite loop. Okay, I'll do one thing. We will put in. Okay, sorry, I just need to stop this. I'll explain the same thing with the for loop. Both are same. I'll just give int I already declare, right? So I equal to 0, I less than 10, I'll give I plus plus. Okay. If I run this, you will get the same output for 10 times this hello world will run. Oh, I have given one more I plus plus here. If I run this, you will get an 10 hello world over here. Okay. If I put a semicolon in this, now you can see if I run this, you will get only one hello world. You can see it over here. Okay, what happens is this for loop will be executed in that same line number 14 for 10 times. Okay, if it is true, it will again go and execute from the beginning. Okay, now this I value will become 1. Now again it will true, it will 2, 3, 4, 5, 6, 7. Once it reaches 10, it will just come out of that loop and it will execute whatever inside that next line. Okay, that is what the semicolon means. So semicolon means until it becomes false, it will be in that same line. Okay, clear? So don't assume it is an infinite loop. It is not an infinite loop. Infinite loop means if your condition is always true, okay, then it is an infinite loop. That is what called as an while of 1. Okay, that is while of always true. That is what an while of 1. That is an infinite loop. The semicolon doesn't mean it is an infinite loop. Semicolon means until your condition becomes false, you will be executing in that same line. Okay.
Okay.
Yeah. Infinite loop actually goes inside. If it is true, it will go inside and execute. But semicolon doesn't. Semicolon will be staying in that same line. That is what this thing is. Right. So what I did over here is if okay, if I remove this, what is meant by that? If it becomes if it becomes 0, that means it is a false, right? If it is 0, that means it is false. So it will execute the same thing. Okay. I'm giving until it becomes not equal to 0. Okay. So if it is 0, it will stay in that same line. If it becomes 1, okay, then the condition becomes false and it will go inside the second line. Is it clear?
Yes.
Okay. So I'm just checking the status register. Where is my status register? Here. If it is 0, I'm just staying in that same line. Okay. If it becomes 1, I'm just coming out of this and I will toggle my pin. Okay. So what is my toggle pin code? Have you remember? What is my toggle pin code? So there is something called as an output data register ODR in the GPIO. We need to toggle that one. Okay. So this is speed IDR. Yeah, this is ODR. So we need to use this GPIOX ODR for that 5th pin. Okay, so we just need to toggle that. So in order to toggle, we need to use which operator?
XR.
XR. Okay. So
Bit-by-6.
yes. So I need to use an GPIOA of ODR, which is XR equal to, I'm just going to give 1 left shift for 5 times because it is PA5. Okay. So I'm just toggling PA5. Okay. So this is waiting for what is that update event, right? Okay. So we are just waiting for this update, I mean interrupt to be updated. That is what this particular line is. Once it is updated, then I'm just going to toggle this pin. After that, I need to manually reset it. That's what the status register says, right? So this will be set by hardware, reset by software. So I need to automatically reset it. So in order to reset, the same thing, timer 6 of the status register. Okay. So I just need to do an AND operation equal to negotiation of this one left shift for 0 times. Okay, so this is resetting the interrupt flag. Okay, that's it, the code. Only this 2 lines of code or I'll say 3 lines of code. So we need to check the status register. Once it is set or updated, then I'm going to toggle this pin. Okay, after that I'm resetting. Again, I'll check if it is set. I'll do this one. Okay, so that is what the program is. I'm just going to check. Is this clear? These 2 lines?
Yes, sir.
So if you have any doubt, just ask me. I will explain it again. Okay, so I'm just building the code. So there is one warning. Okay, so this is for a while class does not code. Okay, there is no issues with that. Okay, so we'll ignore this warning, no issues. I'll connect my board, and this is for timer delay debug. Okay. Switch. Okay, so we are inside this debug mode. So I'm just going to give this resume. And yeah, I'm getting this LED blinking for 1 second. Okay, so check with this. So those who are using the hardware, this is very simple. Like you can directly go to this workpiece simulator, STM. So it is PA5 only, no? Okay, so that is an inbuilt. So I'm just going to delete this sketch.ino. I'm just going to create a new file with main.c, and I'll paste this here instead of STM32F3XX. I'm just going to give an C0XX. So do we have timer 6 here? Has anyone worked with the C0 board? We need to download the C0 datasheet. Okay, those who are working with the hardware, you can just try this one. Okay, I'll check with the C0 datasheet. This is the reference manual STM32C031. Okay, this is an STM32C0 series. Okay, first one is RCC. I'll just directly go to this RCC for I need a data sheet also, right? Okay, so where is my architecture? Okay, this is my architecture diagram. So AHB is connected to these ports, and APB is connected to all the timers. We don't have APB 1 and 2 over here. We have only one APB and one AHB. That's it. Okay, so we just directly go over here, and okay, we have timer 6. No, We have timer 16, timer 17 only. Okay. Shush. Let's say we will use timer 3. Okay. So RCC input output. Yeah. AHP status register. This is ASP status register 2. APB input output port enable. We have EHP only, right? Yeah. So this is EHP enabled register. This is for timers. This is for enable 2. Okay. Why don't I have an EHP yet? Okay. So here I need to use something called as an RCC input output port enabled register. Okay. So here instead of this APB1, I need to use something called as an input output port ENR enabled register, I think, which is equal to we are going to use an PA5, right? So PA5 means port A, where is port A connected to 0th pin. So I'm just going to do this one left shift for 0 times. Okay, so this is for your port. Okay, I'll just maximize this. Okay, next one is timer. For timer 3, I need to use the APB enable register 1. This timer 3 enable. I need to do this one. Okay, so this is APB enable register 1. I'll copy this. This is for timer 3, right? So timer 3 is first bit. So I'm just going to give 1 over here. This is for timer 3. Okay, so this is how you need to read the data sheet of both this architecture diagram as well as this one. Okay. Has anyone tried with the work yesterday, or is everyone using the hardware? If you say so, then I will try only with the hardware. Is anyone using work simulator?
Yes, sir.
Okay, sir.
Okay, right.
So here we have a maximum 48 megahertz frequency. So here we have 4 to 48 megahertz. Okay, let's see. Here I'm just giving in 7090 and everything same, but the timer. Okay, I'll directly go to the GPIO. GPIO mode enable register. This is same 00 and 01, all these things. This is fine. And we will directly go to the timer 3, right? Timer 3 we have given. I think so. Yeah, timer 3. So I'll directly go to this timer 3 registers. First one, I need to enable so I need to give the prescaler value and everything. The steps are same. We just need to check the name. That's it. Whether we have the same name, because here you can see in our previous program, we have APB1 enable register. Okay. For this board, it is APB enable register 1. Something like that will vary. That's it. So this is status register. This is compare capture mode. Compare capture mode. This counter alternate. Yeah, prescaler. So prescaler, I think this is same timer prescaler. So I just need to give timer 3 prescaler. This is timer 3 ARR, and timer 3 count. And here control register also same, I think so. So I'll directly go to this control register. Yeah, this is my okay. I need to give CR1. Yeah, CR1 only. This control enable register, I'm just giving it as this one. Counter enable, I have given one. Okay, this is fine. Here I need to check this timer 3 status enable register, and I'm just going to make that one. So this is also timer 3. I'm just giving. Okay, let's check. Okay, this is status register, right? So I'll directly go to this status register. Okay, we have this UEF. That same thing, I think so. Update interrupt flag. So we'll just check the same thing. Okay, so this is done. And since it is an inbuilt PFI, so we will just directly see this LD4 itself. Let's check if there is any error. So those who are working with hardware, have you got an output? This LD4.
Yes, sir. I see. But you instead of while condition, if condition itself, I'm getting this waiting for update interval.
This one, right? Yeah, we can give this in the if condition also. But what is the difference between this if condition and that is if condition for each and every time it will check the condition and it will go to the next whatever it is. Okay, for example, if you have written something under this, okay, let's say I'm just turning on some other LED. Okay, so if condition will check that. If it is true, it will execute this. If it is not, it will execute this one. Correct?
Got it. Got it. Got it. Yeah.
But I want to wait until the status register change. So that's why I given something like this. That is a difference.
I also update this.
I think it's depends on this clock frequency. I don't know what is this clock frequency for this particular board. We have an 4 to 48 megahertz of crystal frequency. I don't know whether it is 4 or a 48. So that is the thing. Okay, just write this code. Okay, we will try this because the C0 board, it is a pretty basic board and we can't be able to explore much in this one. That is the problem. Okay, write this one. And we will see the PWM generation next. Okay, let me know once you have finished this.
Yeah, have you done? Shall I go to the next program? Or is anyone still trying this? Okay. I'll stop this. Okay. So our next program is PWM generation. Okay. So what is PWM? Any idea?
Pulse width modulations, like the
Okay, what is
brightness
mean by
of
that?
LED we can like reduce. I mean, the voltage we can reduce from the 2.5 to 5 voltage.
Hmm,
So the brightness will increase and dim and bright.
okay, we can. Okay, those are applications. This is dim and light, bright, and this motor speed control. We can able to do this with PWM. These are applications. What is meant by PWM? Yeah, that is pulse width modulation. But what is meant by that?
The time second we can modify it, I guess.
Hmm.
So the width
Changing
of the
the
pulse.
on off
Hmm.
by changing the on with the size of the on, so we
Okay.
can able to change the voltage or something.
Okay. So the pulse width modulation, this itself tells a definition of this. Okay, we can able to modulate the width of the pulse. Okay, that is we can able to change the width of the pulse. So before that, we just need to know what is a pulse. Pulse is it is a simple on and off signal. Is what we call it as a pulse. Right. So let's say this is my pulse. So you'll be having a constant on and off. Okay. So from starting to this is off cycle, this is on cycle. Okay, so this we call it as an pulse. Okay, or we can call it from this to this, we can call it as a pulse. Now, this we call it as a width of the pulse. This one and this one. Okay, we call it as a width of the pulse. In usual condition, what will happen? For example, if your pulse is like in 1 second, okay, we are just generating a pulse of 1 second time period. Let's assume like that. Now what will happen? This on time will be your 500 milliseconds and your off time will be 500 milliseconds. That is 1 second. Okay. Or in technical term, what we call it as, we call this as a duty cycle. Okay. So what is maybe duty cycle is how much percentage of the on time to the off time is what called as a duty cycle. Okay. In default condition, we will be having an 50% of duty cycle. That means 50% of on time to 50% of an off time. Okay, whatever the pulse time you can able to give. Okay, so that will be split into 50% of a duty cycle by default. Okay, now this duty cycle we can able to adjust by using something called as a PWM. Okay, so for example, we can able to adjust the width of the size, or we can able to adjust the duty cycle to something like an 70%. Okay, so now what will happen? Your, let's say this is what your pulses. Okay, for the same 1 second time period, I'm saying if you set it for a 70% duty cycle, this is how your pulse will look like. Okay, something like this.
So now what will happen? You'll be having an 700 milliseconds of an on time to 300 milliseconds of an off time. Okay, for that 1 second time period, I'm saying you can give any time period. Okay, this is not a standard 1 second. I'm just telling it for easy understanding. So 1 second, if you set as a time period for a 70% of a duty cycle, you will be having an 700 milliseconds of an on time and 300 milliseconds of an off time. That is nothing but 70% of on to 30% of the off. Okay, so your duty cycle always represent the on time only. Okay, you can set an duty cycle to 30% or 40% or a 50 or a 60 or a 90, whatever it is, or even an 100%. Okay, this defines the on time. That's it. Similarly, if I set something like an duty cycle of, let's assume I'm just giving a duty cycle of 20%. Okay, so now what will happen? My off time will be 80 and my on time will be only 20. So something like this will happen. Okay, so this is my 80% of off time to 20% of the on time. That is 800 milliseconds of on to 200 milliseconds of off time for the 1 second pulse. Okay, okay, I can able to adjust the width by using this PWM, and this is how my pulse will look like and all these things. Okay, fine. And what is the application of this? Okay, so that's like as I think Arvind said it. I don't know who said that. Okay, so that is the application. Like we can able to adjust the speed of any devices. Okay, so if it is in 50% of duty cycle, that is our default rate. Okay, your motor or your any output device that will be run in the normal speed. Okay, so that is a nominal speed. If you increase the duty cycle, let's assume this is my 5 voltage. Okay, on this is my 0 voltage, this is my 5 voltage. Okay, here off time and on time are same, right? So that means I'm giving the voltage and off time in a pulse rating at the same interval. Okay, now here if I increase the duty cycle, my on time will be higher. That means I am giving the 5 voltage for the longer time and 0 voltage for the lesser time. Okay, so that if it is my LED or if it is my motor, that motor or LED will be on for a maximum amount of time and off for a minimum amount of time, so that it will be brighter or it will run faster as compared to this 50%. Similarly, in 20%, what will happen? It is off for a maximum amount of time period and it is on for a lesser time period. Okay, so it will try to on at the same, I'm just making it an off. Okay, and similarly it is trying to on, I'm just making it an off. Okay, if I do something like this, my LED start glowing at this time, I'm just stopping it. It is again start glowing, it is offing it. Okay, so if you give something like this, my LED will start glowing in the dim, or if I connect a motor, my motor will run at the lower speed. Okay, so this is how we can actually able to adjust the voltage level by using this duty cycle. Okay, clear? So this duty cycle, by using this PWM signal, what we can able to is we can able to generate an analog kind of output. Okay, so in analog, what we refer from this analog is a continuous waveform, right? Or continuous time period. Your voltage will get vary in that continuous time period. Okay, so I can able to generate and 0 to 5 voltage. For example, if I want something like a 2.5 voltage, I can able to give with an analog signal. Okay, whereas in a digital signal, it is not possible. Okay, so this is a signal, it may be either a 0 or a 5 voltage. If you want to give something, it's not exactly 2.5 voltage, but if you want to give something similar to that of this 2.5 voltage range, you can be able to adjust it by using this PWM, by using this digital signal. Okay, So by using this PWM, we can actually able to give something which is approximate to this 2.5 voltage. You will get a 5 voltage only, but it will looks like something ranging from 0 to 2.5 voltage, something like that. You can able to give the voltage level. That is what an PWM is. Okay. So this PWM is one of the most important application that is available in the timer. By using this, we can able to adjust the speed of any devices. Okay, depends upon your input. You can able to adjust how fast your program has to, or how fast your output device has to run. That you can able to give. Okay, so yeah, so we will be having two different programs for this. What to say? The PWM. Okay, so we'll see both the programs. Is this clear? This PWM theory? Any doubts in this?
Clear, sir.
I'm just going to create a new project. This is for the F334 board. This is for timer PWM.
Sir?
Yeah.
If you select C++, also it will be same only, no?
Yeah.
Targeted.
Yes. You'll get this instead of main.c, you'll get a main.c++. Okay.
Sir, are we
So,
using classes and structures in this embed system?
I didn't get you what it is.
Like structures, arrays, and all in programming, we are not using here.
Yeah, we are using. See, here we are using HAL program so that we couldn't be able to see that. Okay, just a minute, I'll show. Let's say, okay, if I go to this AHP1 enabled register, this IOC is already opened up. You can see structure. Okay, inside this API, it is defined in the structure. Okay, since we are not using this things, we are just simply giving that same name as it is so that we will be getting everything. If you are writing the same without any .h file, if you want to write this code, then you need to use this structure and all these things.
Okay.
Yeah.
So if you want to write the .h file, so for like if you for which type of structure, like in one structure, what like component names will be there or what?
Not a component name. You just need to have something like this addresses.
Okay.
Starting address. Okay.
That also is there in data sheet. So
Yes.
like it is mentioning in the
Yes.
data.
Yes. If you go over here,
Yeah, no.
there will be a memory chart. Yes, memories. Sorry. Yeah, this one. Okay, so this is your code memory start with 00 to this one, and your SRAM memory. This is your peripheral memory start with your 0x4. Okay, and these are your each and every peripherals. Okay, this is what start with your APB1. It is start with 4000 to A00. Okay, and this is 4001, something like that, and all your internal peripherals. Yeah.
So one peripheral, whatever address is there for AP, suppose for APB1, or like in one structure, what like what are the
That
numbers
is
are
given in the data sheet, right? If you go to APB1, where it is APB1, okay, in that RCC, I'll just go to APP1 where it is. RCC. Yeah, this one. Okay, you can see if I go to APB. Okay, let's say APB1 is next one. APB2. Okay, APB1. You can see the address value for APB1 is 0x1c. Apart from this starting value, that is 40000. Okay, so here it is 0x1c. That is what this thing is.
Okay.
And similarly, some other APB, this is for APB enabled register. Okay, APB1 enabled register. We have an APB1 status registers.
Okay, so like for APP, there is one
So we will be
structure inside
having,
the structure.
yes,
Okay.
you can see over here, this is a resets thing that start with 0x10.
Okay. Understood.
Okay, so address offset means this address plus that 0x10.
Okay.
Okay, so this is how we will be writing an code. Okay, for the header file.
Okay.
Okay. Okay, why we went there actually?
I asked for whether C++ or same because till now
Okay.
we are seeing just equal to that same.
Okay. You asked for structure and all these things, right? Okay, there
Yes.
we go. Okay. Yeah, so once you generate this IOC file, the first thing is we need to enable the clock, that is the RCC. You just need to bypass this, and your low speed is your crystal ceramic. Okay. Then in timers, last time we used something called as a basic timer. That is timer 6. Okay, this is a basic timer. It doesn't have anything. We're just going to give the delay time period. Okay. This time we need something like a PWM. Okay, so we need a general purpose timer instead of a basic timer. So I'm just selecting timer 2. Right. So inside timer 2, we will be having multiple modes. Okay, like what is the clock source, whether it is an internal clock or an external clock, whether I'm going to trigger by using an interrupt, whether I'm going to use a slave mode for this, all these things I'm going to select. Okay, slave mode disable, trigger source disable, clock source, it will be internal clock. Okay, the same whatever the clock is present inside this board, that is an internal clock. And I'm just going to use some channel 1 here. I'll just move this a little bit left. Okay, once I click this channel, you can see input capture direct mode, output compare mode, output compare channel 1, PWM generation no output, PWM generation channel 1. Okay, here I need to use this PWM generation for this timer in the channel 1. So I'm just going to select this one. Okay, now you can see my PA0 pin is assigned for timer 2 channel number 1 for PWM generation. So if I connect my LED or any devices to this one or motor, this PWM generated output will come for this output device. Okay, that is what this channel 1 is for. Okay, clear?
One more time, sir. One more time.
Okay.
How the
So,
PA0 is it?
Okay, I'll just disable this one. So if I select this channel 1 as a PWM generation channel number 1, okay, this will automatically enable this PA0 as a timer to channel number 1. This pin is actually assigned for timer to channel number 1.
Okay.
Okay, if you want to use some other channel, you can just click this for channel number 2. You'll get a PA1 as a timer to channel number 2. Okay, something like that. If you're using some other timers like timer 1, let's say clock source is an internal clock, And if I select this as an PWM generation channel number 1, then I'll get PC0 as a timer 1 channel number 1. Something like that. Okay, so I'll just reset everything. This is disabled. And timer 2, I'm just going to enable the internal clock, and channel number 1, I'm just going to make this as an PWM generation channel number 1. That's it. Okay. Then in configuration, as usual, if you want this PWM to be generated for a particular frequency, then you can give this prescaler value, counter value, and all these things. Okay. Here your counter value is a 32-bit counter. So this much amount of maximum value you can able to give. Okay. So in clock configuration, what is the frequency? I set the frequency as an 8 megahertz only. So I'm just going to give the same value, like this is an 8000 minus 1. Okay. And here I'm just going to give 1000 minus 1. Okay. So now what will happen? Your frequency will be something like an 1 kilohertz of frequency for this PWM generation. Okay. And we can set the duty cycle. Duty cycle may vary, but the clock frequency will be 1 kilohertz. That is what a clock frequency. Clear?
The duty cycle where we have to set?
That we need to write in the program. That we can't able to set it here.
Okay.
So only the prescaler value, counter value that you need to give. Okay. So first step, go to the timer, any basic time, I mean any general purpose timer, and make the clock source. And you can select any channel. It's your wish. You can select it anything and make it as a PWM generation for that particular channel. Okay. And in clock configuration, as you set the prescaler value, set the counter mode, and set the counter period. That is ERR. Okay. Once it is done, just click Control S and generate the code. Okay. So now the code is generated. You can see over here, this is your timer 2 handle. Okay. And here we have a timer 2 initialization. And here we have this timer 2 initialization program. That is timer 2, my prescaler value, my AR value. Okay. And counter mode. All these things will be generated. So now we need to write the code here. Okay. So as usual, first step, we need to start our timer. Okay. So that has to be given outside this while of 1. First, we need to start the timer. So I'm just going to write this user code begin to. So timer has to be started in the PWM mode here, right? As like last time we started with the interrupt mode. Here we need to start it with the PWM mode. So I'm just going to give al underscore TAM underscore start. Sorry, TAM underscore PWM underscore start. Okay. So HAL timer PWM start. So inside the start, we'll be having again, whether you want to start in an interrupt mode or whether you want to start in a normal mode or a DMM mode, all these things will ask. I'm just going to start this in the normal mode. Which timer it is asking? So this is timer 2 and channel is nothing, but it is a timer channel number 1, right? That is what I have said. So this is timer underscore channel 1. Okay, so I am starting the timer in the PWM mode for this timer 2 for channel number 1. That's it.
Okay. Done with this. Okay, now we need something called as there is something called as a compare. Okay, so your code will automatically compare the value with your previous value and generate the PWM signal, right? So we just need to write the code inside the while of one, that is your infinite loop. Okay, so here what will happen? Let's say I'll start from the duty cycle 0 to duty cycle 100. Okay. Um, okay. And then 100 to 0. Okay, that we will do. Okay, so let's try this. User code begin 3. So before that, okay, I'll just do this. So inside this while of one, I'm just going to declare a variable called as something like an X. Okay. So this X variable, or let's say I'm just giving the, okay, I'll just leave the variable called as X. Okay. So inside this for loop, I'm just going to start this X from 0 to X less than something like an 100 and X plus plus. In our case, it is 1 second, right? So that is 1 kilo. Okay, we will do that. So X start from 0 to 100. I'm just going to increment this X. Okay. In that, there is something called as a double underscore hal. Okay, just give double underscore hal. Just give control space underscore timer underscore set underscore. There is something called as a compare. Okay. So double underscore al timer set compare. Okay. In that it will ask which handle I need to compare, which channel and what is the value. Okay. Which handle, which channel, what is the value. 3 parameters we need to give. So handle name we already know, that is our H timer 2. Okay. That is my handle. And the channel name also I know, that is timer underscore channel underscore 1. Okay. And the time period is X. Okay. So for each and every time, it is going to set this value based on the 0 to 100. So your LED will start from the 0 to the maximum value. Okay. So that is what this program is. Okay. So after this, I'm just going to give some delay for 1 millisecond so that it has to. Okay. So yeah. So I'm just setting the value of this X to this channel number 1 for timer number 2. Okay, I started my timer and then I'm just giving this comparison value. So each and every time this value will be updated to your timer. Okay, so it is connected to PS0, right? Okay, no issues. I'll write the code. So this is 0 warnings and 0 errors. Okay. I had one, there is something called as a logic analyzer. I don't know where I kept that. By using that logic analyzer, you can be able to see the waveform in the PC. Okay. So if possible, just get this one. It is for your own purpose. Okay. That is, there is something called as a Sally USB logic analyzer. Okay. So it is something like not this much amount of price. It is something. Yeah, this one. It's somewhere around 300 to 400 something range. You can actually able to get a waveform for any microcontroller. Okay, it is irrespective of the microcontroller. It has a 8 channel. You can actually able to get a waveform like this.
I'll just show this one. This is the official website of your Sally. Okay, you can actually able to get a waveform like this in your PC. Okay, so this waveform, it's not only for the timer, you can get a waveform for the communication protocols also, as like your I2C value you can able to transfer. There will be a time period you can able to tell what is the clock signal. Okay, for this I2C we'll be having a clock, right? Okay, so that clock we can able to see at which clock pulse you are transferring a data and which clock pulse other device is receiving a data. All these things you can able to visualize it in your PC. Okay, so that is this is very helpful. I already had one. I don't know where I kept this so that I can able to see you. I mean, show you that exact PWM width. If I give the 70%, you'll get something like a 70 duty cycle, something like that. I don't know where I kept it. Okay. So this is what the Sally is. Okay. So if you want, you can get this one, something around some 370 or 380, something like that. You can use it for STM. You can use it for your Arduino boards or TI board. Okay, any board you can able to use. It's a USB only. Okay, we will try that one later. I'll just check it. If I could able to find it, I will show you the waveform in next class. Or something like that.
Sir, I have that
Sally with you.
Yeah.
Okay. So you can connect any channel, okay, with this PA0 board, PS0 pin, and ground to ground of this device, and you can open the Sally logic analyzer and you can able to see the waveform. Okay, it will vary from 0 to 100 duty cycle. Okay, you can able to visualize that.
Okay, first write the program.
Yeah, so first write the program and then try it. Okay, so where it is, yeah, this is what my program. Okay, so I'm just going to build this. I think there is 0 error and warning. Okay, so I'm just going to right click, run as STM. Okay, so let me check the pin number. This is what you got. You just try this code. I'll check the pin number. Okay, it is available here. Sorry, just a minute. I'll check this one. The pin number of PA0 here in the user manual. F334R8. This may be a 0. It is 1, 2, 3, 4, 5, 6. This is connected to 1, 2, 3, 4, 5, 6 pin. And then this is connected to the ground, right? So ground is 1, 2, that pin on the top. 1, 2, 3. Okay, so this 100 is actually pretty fast. Like we have given an 1 millisecond of delay time period, right, in our prescaler value. So I'm just giving it something like 1,000, and I'll just build this. Build it. Okay, and I'll run this one. Okay. So this is like I'm just turning on this one. So what I will do is I'm just going to start from 0 to 1000. And then after that, I will just make it from 1000 to 0 so that it will be on and off. Both things we can able to visualize. So I'll just copy this and I will paste it here. So this is from 1000 to 0. I'm just giving an x minus minus.
We can connect LED to like a bright and okay, we cannot see the board.
If you have an external LED, you can connect it and see. Or I'll just give you one more tip. You have an inbuilt LED on PFI, right? Just click this and see which timer it is. So you can actually able to make your timer to channel 1 on PFI also. Okay, you can just set this timer to channel 1 for PFI instead of PS0. You can able to visualize here. Okay, so some pins is having a multiple alternate functions. Okay, for example, if I click PS6, I can able to use it as a timer 16 channel number 1, or I can able to use it as a timer 3 channel number 1, or I can able to use it as an ADC input number 3. Okay, or I can able to use it as an SPI MISO. Okay, so there are multiple functions over there. Okay, so this PFI is having a timer to channel number 1. So I'm just giving it as a timer to channel number 1, and I will generate this. Let's see, I'm getting an input value as it is. Okay, I'll build this. I'll run this one. Are you getting any output? For PFI pin? No. Yeah. As anyone is trying, are you getting an output?
Sir, and the timer initialization கொஞ்சம் காமிங்க.
ஒரு நிமிஷம். இதுவா?
கோட்ல சார் ஸ்டார்ட் பண்ணுவோம்ல அது.
ஓ அது ஓகே. இதுதான்.
Sir, while of on codes.
Sir, can you show that configuration of that timer to mode and configuration?
யா யுவராஜ் இது மாத்திக்கவா?
Okay sir, நான் ஸ்கிரீன்ஷாட் பண்ணிட்டேன்.
ஓகே. This one, right?
No, not this one. So that above one. Timer mode. Yeah, timer
Okay.
mode. PW. I unable to select PW. Yeah, generation channel. That's not.
In your board. Can you
Here
share the
only,
screen?
sir. Actually, I'm connected in the mobile and
Mobile,
working laptop.
Okay. So what
It's
it is?
showing like a pink color. Pink color only.
Pink color means it is
Pink.
already there is some other pin is configured to that one. So that is why it is showing the pink color. Okay, can you select some other channel instead of channel number one?
Okay, channel 2.
You can select anything. In code, you just have to change it to channel 2. That's it.
Okay.
Yeah.
Yes, sir. You can share the code. Sir. The initial line.
Just a minute. This is starting.
Sir, completed.
Okay.
Shall I try with that Salio to
Servo.
show that? Yeah.
I didn't get you. What it is?
No, that analyzer. So
Okay.
we'll
Sally
see that.
analyzer. Okay.
Yeah.
Can you share the screen?
Yeah. Able to see my screen?
Yes. Do you have the software?
No. Actually,
Okay.
yesterday only
Just
I got it.
click that download logic 2. Scroll down. Yeah, download for Windows. Okay. Have you connected that Sally logic with you with your PC?
Yes.
Okay. So which channel you are connected?
Channel 1.
Channel
1.
1. Okay. Just click the device setting. Okay. Can I just maximize this? Okay. Can you just click something that is under device setting, right? No, on the right side. There are multiple icons. Second icon. Okay. Okay. Can you just open? No, second one only. Second one. Just open the trigger view. Select analyzer. Okay. So this is for, okay. No issues. You can just keep it as it is. Just close this one. No issues. Now just click the run button. Okay. Run your program. Have you run the program?
When combine it.
Yeah.
I think it's a program we need to check once because this x greater than 0 has to come in the format.
Yeah, that is x less than 0. I have changed here. I didn't tell you. Okay. It has to be x greater than 0. Second thing.
Second.
Yeah. Here, line number 112. Your
And I need to
change it to x greater than 0. Okay.
Shall I?
Yeah.
Server
Okay. Just
record
change.
during
No,
charge.
just change this digital. Click that one. No, not that. That digital value. The 24 milliseconds per second. Click that.
Yeah.
No, not that. Okay. Just click the start button. Okay. Now open this drop down. Okay. Change it to something like 8 milliseconds. Okay. Close it. Now start. Which pin you are connected?
PA0.
Okay. Stop this. Okay. Can you just zoom out? Scroll your mouse button. It will be zoom out. No, I think you're zooming in. Zoom out. You didn't get any pulse, right?
Yeah.
Okay. Both this channel as well as ground is connected, right? In your board.
No.
You have to connect the ground also.
Okay.
There is a ground pin in the analyzer, right? Connect that to your board also.
Any ground, right?
Any ground.
Okay.
Okay, now run this. I think it is your D1 channel.
Yes.
But you're getting only the low pulse.
Program is all okay.
Program is okay. I'm getting an output here. I mean, check your LED. Is it glowing?
LED is not glowing, sir.
LED is not glowing. Okay, which pin you have
You mean
connected
to say that
your
blinking only, right? The blink is not.
okay, do one thing. Just go to this IOC. You are using F334 491 board. Okay.
G4.
Go to clock configuration. Clock configuration on top. No, the next step, yeah.
Oh.
Just press Control M. Control M, yeah. Okay. So your see your frequency is 170. What is the prescale value you have given?
Okay, 8080.
So that is too much of time, right?
Yes. Yesterday I changed, but
Okay, no issues. No, not 8. 8 is very small. Just make it 64, something like that.
64.
Yeah. Oh, that is prescaler value. Okay. Select it to something like PLL. Select it PLL. Okay. In that PLL, there is a multiplier, right? Not that. Keep it as it is. Something like 4 or something. Okay. Keep it 1.
Oh.
On the left side, there is a multiplier for PLL, right? Left, right, left side. There is a blue color tab. Yeah. Into 85. There is an into 85, right?
Yes.
Not that. Into 85. Yeah. Change it to something like 16.
60.
16. You are getting an HSI as a 16. You'll get 32. Okay. Change it to 32. Okay. It is 64 megahertz frequency.
Oh.
Right. Okay. Now go to pin configuration. Okay. In your prescaler, make it 64 minus 1.
64,000, right?
No, not 64,000.
Only
64
64.
minus 1. Only 64.
Okay.
We just keep 64. Okay, it is 10 kilohertz of frequency. Now, instead of 1 kilohertz, you will be getting 10 kilohertz of frequency. That's it. Okay, now generate the code. Okay, which pin? Timer to PA0. Okay. Yeah. Save this. Generate the code. Yes. Yes. Now build the code and run.
Also, LED is not blinking.
It's not blinking. Okay, just a minute. Scroll up. Scroll up a little. Up. Okay, a little down. Okay, so it is timer to channel number 1. Okay, scroll down. All timer set, compare timer channel number 1. Okay, I just reduce the delay to something like 1. Delay, all delay. Okay, here also line number 115. Okay, build it and then run.
No, sir.
Still no. But
Mhm.
I'm getting an output, right? Others, are you facing the same issue or are you getting output?
Actually, that PFI didn't configure, I think.
But PS0 you are connected, right?
Yes.
Oh, you didn't connect PS0.
No,
I mean, do
PS0
you
is.
have any external output?
You mean to say external LED RTO?
Yeah, you can see it over here. It will blink.
No,
I
I
mean,
don't have the external LED.
you don't have
In this
external LED. Then you
PFI.
need to configure PFI.
That's what I forgot.
So for me, like if I give
Timer to channel 1, right?
Yeah, timer to channel 1. Yes, Arvind.
yes, so if I like give that timer 4 is connected with the LEDs, those 4 LEDs, but
Mhm.
that channel 1 and the channel 4 I not able to configure because it configured with that LED.
Okay.
PW, that's the problem.
Mhm. So you don't have any external LEDs.
No, sir.
Okay.
Also,
Now
it
I
is
need to.
Yeah, generate the code now, Yuvraj. So this is how your output will looks like. I can see it is actually dimming and start. Okay. This is what the output is. Yeah, you want to see, sorry. Just a minute. Yeah. Sorry. Okay. You can see it is like,
Yes.
okay. This is how it was.
LEDs.
Okay, now we can check it.
Yes. Now LED is glowing. Yes.
Hmm.
Yeah.
Okay, now go to this logic analyzer and check. Yeah, click run. No, you have to connect it to PFI now.
Yes.
This is connected to PEA0, right? Connected to PFI.
Yes. You need to check it.
Yeah. So that is on the left side, it is sixth pin something. 1, 2, 3, 4, 5. Yeah, sixth pin from the top.
Okay.
Connected?
Yeah. And the ground also to the same side, or
Oh, no.
any
Any
more?
ground is fine. Any ground is fine. Okay, now open logic analyzer. Now click, run the program. Is it running?
Yeah,
Your
program
LED is
running.
glowing, right? Okay,
Yeah,
then start.
yeah.
Now you are getting, right? Okay, stop it.
Yeah.
This is fine, stop. Okay, now zoom in. Okay, you'll find the pulses. Okay, if you just move your mouse over there, you will get that time period of off time and on time. Okay. So total time period is 996 microsecond. That is one millisecond.
1
And
millisecond.
your on time is something like a 30 and off time is 70. Okay, you can see on the right side duty cycle is 25%. Okay. So it is actually reducing. So zoom out a little. Okay, move your cursor to the right. There is a scroll bar on the bottom right. Just move it to the right. Now it is 25% duty cycle. On the bottom there is a scroll bar.
Here.
Just move it to the right. No, not there. Yeah.
This one.
Move it to something light. Okay, now move your cursor over there. You will get some other different duty cycle.
Yeah.
See, it is increasing
31.
to 31. Okay, so if you move it further down, you will get more duty cycle because we are increasing from 0 to something. Now it is decreasing. That is 0 to 100, 100 to 0, right?
Yeah.
Yeah. So this is how you can able to measure the duty cycle. So now this is 10%.
10%.
Yeah. Okay, so frequency is 1 kilohertz frequency constant for all the pulses. Only the duty cycle will vary.
Okay.
Okay. Yeah, so this is how we can actually able to measure the waveform. Not only for the timer, you can actually able to see the waveform for your communication protocol also by using this logic analyzer. Okay. So if you wish, you can just get it. So it is like your oscilloscope. In your college days, you might have studied the oscilloscope, right? You can able to see the waveform of your output. Okay. So this is like a digital waveform of your digital form of your waveforms in the board. Okay, so this is somewhere around 350 something will come. If you want, you can get it on
Can you
your.
share the link in WhatsApp, sir? Can you share the
Yeah,
link?
I can share that. Yeah, okay. So this is what the timer. So we saw the timer for delay mode. Okay, and this is the timer for the PWM generation. Okay. So WhatsApp. Okay, I'll put that in the WhatsApp. So if you want, you can get it for it. Yeah. So okay, so tomorrow you don't have class. Okay, because Steve, after tomorrow we are having a workshop in the office, so I just have to prepare for that workshop. So we will have a class on Monday, the next class. Okay.
Okay.
Okay, sir.
Okay. So thank you. Bye. We'll see you on Monday.
Bye.
Thanks.
Thank you.
Bye. Thank you. Bye.
Thank you, sir.
Yeah. Thank you. Bye.
Thank you, sir.
Yes.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you. Bye.